In this video, we have two objectives. First is you can determine the velocity of a distance time graph as being positive, negative, or zero. Second, be able to determine if acceleration from a distance time graph is positive, negative, or zero. Let's first define the velocity. The equation for velocity is v equals d over t. Remember that d is your displacement, or in this case, we're going to just talk about distance, and t is your time elapsed. So if you divide your distance divided by time elapsed, that's going to be your average velocity. It is a rate where one unit is compared to another unit, and that could be meters per second, miles per hour, kilometers per hour, whatever we're measuring in. What's important about distance time graphs and the velocity is that when you have a constant velocity like this picture here, it turns out to be a line. And actually the slope m of that line ends up being your velocity v. So if you find the slope of a line, it's a constant velocity, you will find the velocity of the object itself. Now whether it's positive or negative depends on the graph. So we got three examples here. This first graph has a line moving down to the right as time progresses. So the distance is getting smaller as time progresses, and it's a line, so it's a constant velocity. So we know velocity is constant, and in this case we know it's going to be a negative velocity because the time or the distance is decreasing. So it's like an object coming closer towards you. This one to the right is a positive constant velocity because it's getting further away from the source or you. So constant velocity, and it's positive because it's getting further away. The distance is increasing as time goes this way to the right. The third drawing here is one of a horizontal line. And when the line is horizontal, that means as time goes, the distance is neither going up or down, so you're not getting further or closer. That means the object is stationary or not moving. So if the object is not moving, object isn't moving, velocity is equal to zero. Those will always appear as a horizontal line in a distance time graph. So whenever you see a horizontal line, that indicates the object is not moving or the velocity is zero. Now all three of these velocities are constant. They're not changing in the middle. Whenever it starts out, like this could be negative 10 meters per second. All throughout the line, it's negative 10 meters per second. What if we had graphs that had different velocities throughout? That's where you have graphs like these three. First two, you'll notice that they're both going, the velocity is both positive for these, but you'll notice that they're curved. This one is curving towards the horizontal, so it's kind of getting flatter, we'll say, or more horizontal-like. This one's increasing, getting more vertical. And this is where acceleration comes in. Acceleration is a change in velocity. So I'm going to define that here. Acceleration is a change in velocity. There's two ways of doing that. Number one, you could change the direction. We're not going to focus on that right now. We're going to focus more on the speed aspect. If you change speeds, that's an acceleration, either positive or negative. If you are a graph like this and you're increasing velocity, it's positive. The acceleration, though, is it negative or positive? Is the object speeding up or slowing down? Well, on a graph like this, the steeper the line, the faster it is because you're covering more ground in less time. This case, we have a increasing velocity, but you'll notice that it's trending towards the horizontal, which is a zero velocity. This is slowing down because it's getting, put that in quotes, it's an informal word, getting more horizontal. That's how you know it's slowing down. And because it's slowing down, we call this a negative acceleration. It's a negative acceleration. The picture next to it, you'll notice, is getting more vertical. This indicates that it's speeding up, or we call it a positive acceleration. So when things speed up, the change in speed is a increase. We call that a positive acceleration. When the change in the velocity or speed is a decrease, it's a negative acceleration. You may have also heard people use the word deceleration. That means the same thing. Negative acceleration or deceleration. We're going to be using positive and negative acceleration in this class. The third picture. No curves, but we have three different main sections here. I have the first section, the horizontal line. I have the second line, and then I have this third segment. Horizontal line, you remember, means that this object's not moving. V is equal to 0. Zero velocity. Here, this second section, we're increasing the distance between the object and us. We'll be right here at the origin. So increasing, it's going to be a positive velocity. So POS, that's velocity. Last section, decreasing the distance. This is going to be a negative velocity. All four of these sections have linear parts. So therefore, they're constant within, the velocity is constant within their own windows. There's an acceleration here and here because you're changing the velocity, but in terms of within the window, all these are constant velocities. So when you're looking at examples of graphs, you need to go look at two things. First, the velocity. Is it trending upwards? Is the distance getting larger between the origin and the actual object itself? If it's increasing, going up to the right, that's going to be a positive velocity. If it's going down to the right, that means the distance is getting smaller over time, therefore it's a negative velocity. Now, how do you judge the curves? The curves tell you whether or not it's accelerating positive or negative. If there is no curve, like this third one here, it's a line, we know it's a constant velocity because the slope does not change. These two, though, if you look at this curve, if we draw a tangent line, we'll call it, right there. It's pretty steep. If I draw a tangent line here, just skim the edge of the curve, you'll notice that the line goes from pretty steep to pretty shallow. And if you keep going here, the lines get shallower and shallower, or more like a horizontal, or slowing down. The other example we have here, we have a pretty shallow tangent line here. If you were to draw a tangent line over here, you'll see how steep it gets. So if you want to just follow with your pen along the curve, you'll see that the line gets steeper. And when that happens, it's an increase in velocity. Velocity increases, that's a positive or acceleration. If a velocity decreases, like in this graph, it's a negative acceleration. If velocity doesn't change at all, it's constant, the acceleration is 0. So our two objectives were determining whether or not the velocity was positive, negative, or 0 from a distance time graph. We went over that. If velocity is increasing to the right, it'll be going up. If it's negative, it'll be going down. And if it's 0, it'll be a horizontal line. Acceleration, positive, negative, or 0. Acceleration will be 0 for a constant velocity or a line. If acceleration is positive or negative, it will be speeding up or slowing down. So I'm talking about these two examples. This is a negative acceleration. The lines are getting more shallow or less steep. Here is a positive acceleration because the lines are getting more steep.